chapter Acids and Bases.
This slide presents the overview of the chapter. Learning objectives. By the end of this chapter, you will be able to
Define acids and bases. Classify substances into acids and bases. Define indicators. Describe the effect of indicators on different substances. List out the properties of acids and bases. Explain acid rain. Discuss the neutralization reaction. Identify the acidic salts, basic salts, and neutral salts. Mention the uses of acids, bases, and salts.
Introduction. Before entering into the chapter, follow the instructions shown on the screen. Click each tab to know more.
We know that large number of substances such as lemon, tamarind, common salt, sugar, and vinegar have different tastes. Even our food has a lot of variety, and also different items have different tastes. Do you know what makes lemon and vinegar sour in taste? Do all the items have the same taste? In what way they are different? What kind of tastes food substances we eat have? Let us try to find the answers and understand the reasons for some of them. Find out from these substances they taste sour, bitter, sweet, and salty by choosing correct one. The substances such as curd, grapes, lemon juice, orange juice, tamarind, etc. have sour taste. The salt substances found in nature are prepared artificially or called acids. The substances like baking soda solution, soap solution, etc. have a bitter taste. As these substances do not have sour taste, they are not acids. The substances which have a bitter taste and feel slippery, that is soapy touch, are known as bases. Let us know about natural acids. The acids which are found in plants and animals are commonly called natural acids or organic acids. The table given below gives the names of naturally occurring acids and their source. Here, let us perform an activity to know about natural indicator. Click each tab to know more. Take some turmeric powder. Add a bit of water to it. Now prepare turmeric paste. Rub the turmeric paste on a white paper. Cut thin strips of this yellow paper. Put a drop of soap solution on the strip of turmeric paper. Observe the changes. Repeat the same procedure with lime water and observe the changes. We have observed that the turmeric changes color when soap water or lime water is added to it. Finally, we learned that the substances that indicate a change in color when some substances are added to them are known as indicators. So turmeric powder is a natural indicator. Let us know more about the natural indicators around us. The special types of substances which change their color when come in contact with acidic or basic substances are called indicators. These are used to test whether a substance is acidic or basic. The following are the natural indicators around us. They are turmeric, China rose petals, phenolphthalein solution, methyl orange, litmus solution. Click each tab to know more. Turmeric. Turmeric as an indicator identifies basic solution only. Its color changes to red when come in contact with basic solution. Its color does not change in acidic or neutral solution. China rose petals. China rose is a flower which has pink petals. The colored solution extracted from it is light pink color. When used as an indicator, its color changes to green in basic solutions and dark pink color in acidic solutions. Its color does not change in neutral solutions. Phenolphthalein solution. Phenolphthalein is an organic dye prepared by dissolving it in alcohol. Its solution is colorless. When it comes in contact with basic solution such as soap solution, shampoo solution, washing soda solution, etc., its color changes to deep pink color. But when the solution is acidic or neutral, it remains colorless. Methyl orange. Methyl orange is one of the indicators commonly used in titrations because of its clear and distinct color change. It gives red-orange color with acids and yellow color with bases. Litmus solution. A litmus solution is made from a purple dye. It is extracted from the lichen, which is a plant belonging to the division Phenolphthalein. The solution of litmus in distilled water is mauve, that is purple in color. This solution is called litmus solution. Litmus is available in the form of solution or in the form of stripes of paper. Litmus paper is available in red and blue colors. A litmus paper is used to test the acidic or basic nature of a solution. When a litmus paper touches an acid, the blue-coated paper changes to red. Similarly, when litmus paper touches a base, the red-coated paper changes to blue. Here, let us do an activity to know the effect of blue and red litmus papers of different solutions. Drag and drop the test solutions into their corresponding blocks based on the effects of the litmus paper. The solutions which do not change the color of either red or blue litmus are known as neutral solutions. These substances are neither acidic nor basic. The paper strips like litmus paper strips change color based on the nature of the material put on them. These are all indicators. They tell us whether a substance is acidic or basic. They are used extensively in studying substances and their properties.
Knowledge check. Attempt the following questions to check your understanding.
The substances which give a burning sensation when touched with bare skin are acidic in nature. For example, when a honeybee stings a person, it injects an acid in that person's skin, which causes pain and irritation. The substances that contain acid are shown on the screen. Let us know about the basic nature of the substances. The substances which are soapy to touch are basic in nature. Some substances we use in our daily life which contain bases are shown on the screen. Here, let us perform an activity to know about the nature of the substances. Click each tab to know more. Take a long magnesium ribbon. Use a sandpaper to rub and clean the ribbon. Hold the ribbon using a pair of tongs. Burn the ribbon using a spirit lamp or a burner. Collect the white ash in the watch glass. Take some water in beaker. Dissolve white ash in it. Now, test this solution by dipping the blue and red litmus papers. Observe the changes in the color of litmus papers. In this activity, we observe that the red-coated litmus paper changes to blue when it touches the solution, whereas the blue-coated litmus paper is unchanged. Finally, we learned that the oxides of magnesium, when dissolved in water, form magnesium hydroxide. Similarly, oxides of potassium and sodium, when dissolved in water, form potassium hydroxide and sodium hydroxide. All these are basic in nature. They would be soapy to touch. Let us know about the reaction between acids and metals. Pickles and other sour substances are acidic in nature when they are stored in metal containers made up of brass or copper. They are spoiled. This is due to the reaction between acids and metals. To avoid this, the inner side of vessels made up of brass and copper coated with tin. The table given below shows the difference between acids and bases. Let us know about acid rains. As the name indicates, the rain which contains excess of acids is called acid rain. When harmful gases like sulfur dioxide and nitrogen dioxide react with moisture present in air, they form nitric acid and sulfuric acid. These acids, when dropped down on earth along with rain, called acid rain. Acid rain causes skin irritation, inhibits germination of plants, causes corrosion to bridges and buildings. It changes the fertility of the soil, destroys plants and aquatic life. Acid rains are also witnessed in Andhra Pradesh state in Visakhapatnam district. Here, let us perform an activity to know about the reaction of acids and bases with metals. Click each tab to know more. Place a retard stand on a table. Adjust and fix the test tube on horizontal rod. Take about 10 ml of dilute hydrochloric acid, HCl, in a test tube. Now, add a few pieces of zinc granules in it. Observe the surface of zinc granules. Insert one end of delivery tube into the test tube through a cork and insert the other end of the delivery tube into a glass tub. Fill the glass tub with soap water. Now, the gas evolved from the test tube passes through the delivery tube into the soap water. At this time, bring a lighted candle near the gas-filled bubbles in the tub. Observe the reactions. Make a note. Be careful while handling the acids. In this activity, we observed that a colorless and odorless gas comes out of the delivery tube. Bubbles are formed in the soap solution. The gas evolved burns with a pop sound. Since the gas evolved from the tub gives pop sound near the burning candle, it is confirmed to be hydrogen gas, that is H2, produced by the zinc granules and diluted HCl solution. Finally, this activity shows us that hydrogen gas, that is H2, evolves when an acid reacts with a metal.
Select a suitable answer from Group B for Group A and drop it in the bracket provided against A.
Here, let us perform an activity to know about neutralization reaction. Click each tab to know more. Take a test tube, clean it using a clean dropper. Pour 10 drops of hydrochloric acid carefully in the test tube. Now, add 2 drops of phenolphthalein indicator solution. Observe the color changes. Now, add sodium hydroxide solution drop by drop to the test tube. Shake it well after adding each drop. Observe the change in the color of the solution. Keep adding the sodium hydroxide drop by drop until the color begins to turn pink. Once again, add drop by drop of hydrochloric acid to the solution mixture until the solution in the test tube becomes colorless. In this activity, we observe that there is no change in the color of hydrochloric acid while adding phenolphthalein solution. The color of the solution in the test tube becomes pink by adding a drop of sodium hydroxide solution. The pink color of the mixture solution becomes colorless by adding a few drops of hydrochloric acid. Finally, we learned that if we add excess base, that is sodium hydroxide, to acidic solution, that is hydrochloric acid, it converts to base. Similarly, we can change base into acid. We also learned that the effect of base is nullified by an acid. When acids and bases are mixed in definite proportions, they give a neutral solution. The reaction of an acid with a base produces salt and water. Let us know about salts. We have seen in the process of neutralization, both acids and bases are mixed in definite proportions, produces salt and water. We also know that the reaction between an acid and a base is known as neutralization. For example, by neutralizing hydrochloric acid solution with sodium hydroxide, that is caustic soda solution, a salt, sodium chloride, is produced. Production of salt depends on the type of acid and base. Note: all neutral solutions are not salt solutions. Sugar or starch solutions are neutral solutions, but they are not salt solutions. Let us know about the fertile land, organic manures. In recent years, the use of chemical fertilizers increased. Though the use of chemical fertilizers increases production, it affects the nature of the soil. Some fertilizers increase the acidity of the soil and some its basicity. Thus, the use of natural organic manure is preferred these days. Types of salts. Salts which change blue litmus to red are acidic salts, and salts which change red litmus to blue are basic salts. Some salts affect neither blue nor red litmus. These are called neutral salts. The following table gives the information about the acidic salts, basic salts, and neutral salts. The following tables shows the use of acids, bases, and salts.
Knowledge check. Attempt the following questions to check your understanding. Select a suitable answer from Group B for Group A and drop it in the bracket provided against A. Keywords. List of keywords are shown on the screen. Summary. Let us recap the highlights of this chapter.
The substance, such as curd, grapes, lemon juice, orange juice, tamarind, etc. have sour taste. The sour substances found in nature are prepared artificially or called acids. The substances like baking soda solution, soap solution, etc. have a bitter taste. As these substances do not have sour taste, they are not acids. The substances which have a bitter taste and feel slippery, that is soapy touch, are known as bases. The substances that indicate a change in color when some substances are added to them are known as indicators. The solution of litmus in distilled water is mauve, that is purple in color. This solution is called litmus solution. Litmus is available in the form of solution or in the form of strips of paper. Litmus paper is available in red and blue colors. The blue coated paper changes to red when it touches an acid. The red coated paper changes to blue when it touches a base. The solutions which do not change the color of either red or blue litmus are known as neutral solutions. These substances are neither acidic nor basic. The substances which give a burning sensation when touched with bare skin are acidic in nature. The substances which are soapy to touch are basic in nature. As the name indicates, the rain containing excess of acids is called an acid rain. Acid rain causes skin irritation, inhibits germination of plants, causes corrosion to bridges and building. It changes the fertility of the soil, destroys plants and aquatic life. The effect of base is nullified by an acid. When acids and bases are mixed in definite proportions, they give a neutral solution. Salts which change blue litmus to red are acidic salts, and salts which change red litmus to blue are basic salts. Some salts affect neither blue nor red litmus. These are called neutral salts.
Read the questions and attempt the answers on your own. You can click Answer for your reference.
Follow-up work. Collect different flowers and prepare their natural indicators with the help of filter papers. Prepare red cabbage juice by boiling a piece of red cabbage in water. Use it as an indicator and test the acidic and basic solutions with it. Present your observations in the form of a table. Bring the soil sample of your area. Find out if it is acidic, basic or neutral. Discuss with farmers if they treat the soil in any manner.
Test your understanding of the lesson by taking the mock unit test.
You have successfully completed the chapter Acids and Bases.